Greetings everyone. Today, me and my fellow mates Tushar and Shruti are here to present on system on chip applications, under which we have chosen a topic, a system on chip approach to enhanced learning and interdisciplinary robotics. So this will be our contents for today's presentation. Introduction, technology used, innovative concept, disadvantages, and we'll be concluding it with the results. So a system on chip technology provides an abstraction between high-level softwares and low-level input-output and control hardware. So basically, SOC, system on chip, is a compressed version of ICs. The aim of this paper is to provide students with a simple FPGA-based framework for hardware access and development. Basically, SOC can be used for controlling a single LED or complex modular and aggregated robots. Basically, SOC can be seen in our computers, in PCs, and in mobile phones. So let's continue it with the system design. In the left side, you can see that robot and PCs are there, wherein robot contains the mechanics part and the PC has the application. On the right side, it is broadly explained that it has main four components: the robot, the input-output module, embedded computer, and the PC. Basically, robot contains mechanics, the sensors, and the actuators, which performs all the actions, and the input-output module that contains the input-output function, the input-output registers, single conversion, bus interfaces. And the embedded computer contains all the input-output libraries, the common libraries, the operating system, and the CPU. And the PC has all the connections in it, that is applications, the robot library, another operating system, and the link layer. Yes, sure, you can continue.
Thank you, Tejas. The technology used in this paper is TOSNet. The TOSNet framework is developed on the Xilinx Spartan 3 family of FPGA and can be used for evaluation, demonstration, development board. Now, what is TOSNet? The TOSNet framework is a set of interconnected nodes, as we can see at the right of the slide, where each node contains the gateway modules. A RAM that is mirrored across the network has the role of global distributed input-output register in cooperation with necessary circuit outside the FPGA. Now, talking about the innovation concept, just change the slide. Thank you. The innovative concept is the TOSNet framework provides a very transparent conduct between high-level software and input-output. As the major part of the framework is implemented in reconfigurable hardware, there are no performance issues. The framework can be accessed by any application that can access a serial port and or an Ethernet socket. TOSNet has made it feasible to replace CPU microcontroller-based interfaces with FPGA based in the cores. Next slide, please. The students have been able to utilize the flexibility and performance of the FPGA to create a combination of input-output interfaces that exceeds the ability of normal microcontrollers. The students have been able to write high-level application programs in Java and C# that interacts with their input-output applications through micro TOSNet. The next part will be explained by Shruti. Thank you.
Thank you, Tushar. I'll be explaining about the disadvantages. So programming of FPGA requires knowledge of Verilog programming, as well as the digital system fundamentals. So the programming is not as simple as the C language, and the things are a processor and everything is based on the hardware. So moreover, engineers will have to learn about the simulation tools. FPGA consumes high power, they are expensive and complex. Also, considering the research quite strong in maths and software engineering, but then they have a limited knowledge of electronics and computer architecture. So that becomes one of the limitations. Moving on, we have the results section. Tejas, could you please? Yeah. So in the results section, we can see there is a diagram wherein the students are given the FPGA board along with the user's guide containing the examples of simple input-output related functions in VHDL. So here the FPGA board is used for the introduction, wherein the breadboard is there, wherein the LEDs and the resistor array has been added. There are some simple timers, the PWM generators, and the digital inputs controlled by the mu TOSNet, which was explained by Tushar. Moving on to the conclusion, let me give you a brief summary of what we have been talking about for the past few minutes. TOSNet has made it feasible to replace the microcontrollers or the CPUs based interface with the FPGA. So to summarize, the students have been able to let the high level software on a PC to interact with the aspects of the physical world, considering the different time frames. As a major part of the framework is implemented in the reconfigurable hardware, that is the FPGA, there are no performance issues or derived issues about the resource sharing or probably the timing or deadlocks. Thank you.
Thank you.
Thank you.